In section 1.6, we're going to be looking at a lot of different functions, and these will be our parent functions. We need to have an understanding of what these graphs look like, and then we will move them around from there. And with these, we should be able to answer the following questions to be able to describe the function. We should be able to determine the domain and range, as well as the x and y intercepts. We should be able to determine if the function is even or odd or neither, and if it has symmetry to the x-axis, the y-axis, or the origin. We should also be able to list the intervals in which the function is increasing, decreasing, and where it is constant. We should be able to find the local mins and maxes, and we should also be able to have 5 critical points per graph, so that as we move the graph, we can pay attention to those critical points. The first function is a constant function, where f of x equals a constant value. This is going to result in a horizontal line, whatever that value is. Our next function is the identity function, f of x equals x. Remember, this is our line y equals x, where each of our y values and x values are the same. Our square function makes a parabola. This is f of x equals x squared. Our next function is the cube function, f of x equals x cubed. This is a square root function where f of x is equal to the square root of x. Our sixth function is the cube root function. Here f of x is equal to the cube root of x. Our seventh function is the reciprocal function. Here f of x is equal to 1 divided by x. Remember, we have asymptotes at the x and y axis where this line will approach but never intersects either one of those axes in this form. Here we have the absolute value function where f of x is equal to the absolute value of x. Remember, when we take the absolute value of a number, it will always be positive. We can see that with the graph here. Here we have the greatest integer function where f of x is equal to an integer or rounding x. So you can see that our graph stays constant as we go, where we're rounding these values to the greatest integer. Our last function is a piecewise function. This would be a function in which we have f of x made by different functions where we define the domain of each of those. Here's an example of a piecewise function. Here we have f of x is equal to, and then we have 2x plus 5 where x is between -3 and 0, and f of x is equal to -3 if x equals 0, and f of x is equal to -5x if x is greater than 0. So let's just start at this first one where we have our values from -3 to 0 for x, and the function is 2x plus 5. So if we plug in -3 for x, 2 times -3 is -6 plus 5 is -1. So that would be a point on this graph, -3, -1. That's going to be this point right here. And if we plug in 0, 2 times 0 is 0, plus 5 gives us our point 5. So from -3 to 0, we go from this point to this point. Now this is an open circle at this point. It is not filled in because we're not equal to 0 here. So that would be an open circle. Now where x is equal to 0 is at the point -3. That's right here. So this one is filled in completely. That is where this function is equal to 0. And now where x is greater than 0, we have -5x. So that's going to go from, again, if we plug in 0, -5 times 0 is 0, there's our open circle. And now we can plug in a value greater than that. Our slope is -5. It's going to go down 5 over 1, goes through that point, and it continues to go where all of those values are greater than 0. So now we would have a line. Up here we have a segment. We do not have anything less than -3. Next thing I want you to do is look at this graph and determine the domain, the range, our intercepts, and then answer the question, is this graph continuous? So when looking at this graph, we can see that our domain, our x values, go from -3, -3 is included, so we have the bracket, to infinity because this line continues on forever. So then we have all those positive values. So our x values, our domain goes from -3 on up. Our range, now we're talking about our y values, we go from 5, and then it is everything less than that because this line continues on forever. So we'll go from -infinity up to 5. Our intercepts, our x-intercept is right here where the line crosses. If we wanted to plug in, that's going to be up with our 2x plus 5. If we want to plug in and solve that for 0, we would find that we're at -2.5 for our x value, 0 for y. Our y-intercept is this point right here where y is equal to -3. And then is the graph continuous? To answer that, we can start at this point, and if we can draw this entire graph without lifting the pen, then it is continuous. But as soon as we have to lift the pen to go to another point, now that graph is no longer continuous. So in this case, no, the graph is not continuous.